Okay, we finally reached day 3 of the limits in section 1.4, and day 3 is probably the easiest day, but we're talking about something very different from what we have previously spoken. Previously we've done the limit as h goes to 0 to find our first derivative, and the limit as x goes to a number to find the limit of a function, which was the y value. So here we're going to do the limit as x goes to infinity, which is kind of a strange thing since x going to infinity is a concept that we're not used to thinking about. So I start out in the note saying, can you sketch a graph that shows x going to a certain f of x going to a certain value if our x is getting bigger and bigger? So the first thing I asked you to find is the limit as x goes to infinity of f of x equals 4. So that means that if the limit as x gets bigger and bigger is 4, then what does that mean? And how could you possibly sketch it? So I said it could look like what I have drawn here. However, it could also look like, let's see, how about if I draw it on top? It could also look like this, coming down. The only requirement is, as x gets bigger and bigger means you're going to the right on the number line for x's, my y value will be approaching 4. So basically what you're identifying is a horizontal asymptote. If the horizontal asymptote is at y equals 4, then you have demonstrated the limit of f of x as x goes to infinity is 4. So now look at the next one. It says the limit as x goes to infinity of g of x is -1. So all you have to do is make sure that your function as x goes bigger and bigger approximates y equals -1 as x goes to infinity. So let's see, what else could I have drawn here? How about, couldn't I have drawn something like this? Let's say your function comes up and it's going to go out to infinity. As long as your function is approaching the horizontal asymptote y equals -1, you have demonstrated that you understand what limit looks like as x goes to infinity. If you always think in terms of horizontal asymptotes, then you'll be good to go. Now, this is the graphical analysis. On the next page, we're going to do the algebraic analysis. So let's do that now. In terms of the algebraic analysis, there's two different equations here that we're going to talk about. The first one says, or I should say expressions. The first expression says the limit as x goes to infinity of 3 over x squared plus 3. So when you want to analyze it algebraically and not graphically, you're going to mentally replace the x with infinity. Think about what that does to your denominator. Doesn't it make your denominator get bigger and bigger and bigger? And if you have a denominator that's very, very large, aren't you making your fraction very, very small? So that in the limit, 3 over a million or 3 over 100 million or 3 over 100,000 million is pretty much 0. So in the limit, as the function 3 over x squared plus 3 has an x value that approaches infinity, my value of that function or of that limit will be 0. Okay, so basically that is your horizontal asymptote. Your horizontal asymptote is at y equals 0. So in the limit, as x goes to infinity, the y value will get closer and closer, never reaching, but will get closer and closer to 0. And that just follows our definition of horizontal asymptotes when you have a function where your denominator is bottom heavy. Okay, so now look at the next one. Here we have the limit as x goes to infinity. Okay, we have that concept down. But now we have a fraction or a rational function that's 8x minus 5 over 2x plus 3. So I basically, if I try to mentally plug in infinity, don't I have infinity over infinity, and that gives me no information. So there is another algebraic manipulation, and I'm sure you're thinking, of course there is. There is, and that algebraic manipulation, which allows us to clear away the cobwebs, if you will, is to take every single term and divide it by the highest power of x that you see. The highest power of x is x to the 1. So in this step right here, I take every single term and divide it by x to the first power. What happens to the 8x over x is that it reduces to 8. What happens to the 2x over x is that it reduces to 2. In the limit, if you plug in infinity now in the fraction 5 over x, then you're going to basically have 8 minus 0, right? In the limit, as x gets bigger and bigger, that 5 over x will go to 0, and 2 plus 0, because 3 over x will also go to 0, and you're going to end up with 8 halves, or 4, being the limit. Now, let's think about this one. How do you figure out horizontal asymptotes if your x's have the same power? Don't you just take off the coefficient? And isn't that coefficient going to give me y equals 8 over 2, which reduces to 4? Okay, I want to do one more of these because sometimes the highest power is not 1, and you have different powers of x in your equation. So on the next page, let's do one more example. Alright, let's say this is our example, and I want to figure out if I plug in infinity for x, what happens. So I end up having infinity over infinity again, only it's like infinity squared over infinity, which doesn't mean a whole lot to me. So let's do our algebraic manipulation once more. So remember, we're going to divide by the highest power of x, and in this case it is x squared. So I'm dividing my first term by x squared, plus my second term by x squared, and then all over x squared minus 7 over x squared. So what's going to happen with that? My first term, let's see, this becomes a 1. Okay, in the limit, 4 over x squared is 4 over a very large number. So as x goes to infinity, that's going to become 0. X over x squared reduces to 1 over x, and in the limit, that's going to go to 0. 7 over x will also go to 0. So what do I have? I have 1 over 0. So what does that mean? Well, that's just undefined. So in this case, my limit is undefined. Because I cannot divide by 0, so it's undefined, so the limit does not exist. So think about that. Make sure you are comfortable doing the algebraic manipulations. And now we are done with section 1.4 of chapter 1. So you have a good handle on the 3 days of limits. So go ahead, use these notes, try to do the last homework assignment, and you'll be all set.